Good day, everyone. It's Alan Schimmel, DevOps.com, Security Boulevard, and you're here for another great webinar. Today's webinar is brought to us by our friends at Signal Sciences. If you follow the security scene, you probably know Signal Sciences. They do some groundbreaking kind of work. But we actually have a bit of a case study today. Signal Sciences have brought in some folks from Netflix, and we're going to really take a bit of a deep dive into Netflix's layered approach to reducing risk of credential compromise. I'm going to talk more about that in a second, but first let me just give you some ground rules. We use the GoToWebinar control panel here for our webinars, and for most of you, that means you have a control panel in your upper right-hand corner. A couple of areas that are important. We have set aside time for questions today. We've got two great folks on the panel, and I encourage you to ask them questions. Rather than waiting till the end, though, and making the mad rush in for who types better, if you look at the question section of your control panel, you can see you can expand it, and you can type your questions in real time. They're queued, they're set up for us, and we can get to them and get your answers for you. We can write to you privately on that as well if it's just a question with you. So if you have any questions for our panelists, please use the question section. Now, on our Security Boulevard and DevOps.com webinars, we use the chat section if you're having technical difficulties. Audio's not playing well, slides aren't advancing, but you can still get to that chat section. Type your problem in there. We do have engineers standing by who will try to help you and make sure you get the most out of this webinar. Lastly, I want to mention that we are giving away five $50 Amazon gift cards to random people we'll choose in the audience today. The only caveat is you've got to be on to win, and we'll announce the winners at the end. If you're not on, you won't be chosen. So if this scintillating, this is really good stuff from Netflix, but if that alone isn't enough to keep you here, maybe the Amazon gift cards will, I don't know. But we will pick the winners at the end. So with that being said, let us return now to our webinar today. As I said, brought to us by the folks at Signal Sciences. They brought along folks from Netflix. Our presenter is Will Bengtson. He's a senior security engineer at Netflix. And will be joined by none other than James Wickett, Chief of Security Research, I believe. Well, James can tell you his exact title, but that's where we are. Will, James, can you hear me?
We can.
Fantastic. Gentlemen, that was your sound check. I'm going to turn things over to you now.
All right, thanks, Alan.
Okay.
Well, so I'll kind of tell you a little bit about Signal Sciences, and then we'll get into the Netflix piece with Will. And really, we're just really excited to be working with a great company like Netflix and with great folks like Will. And so we're just excited to bring them on this at DevOps.com podcast here. So wanted to tell you something about Signal Sciences. Signal Sciences, if you haven't heard of us, we provide a next generation web application firewall and RASP. We provide defensive technology where you traditionally would have put like a web application firewall. We do that, but we do it with added telemetry, added defense. We are a tool that fits in your development and operations and security teams cohesively and integratively. On the next slide here, one of the things that kind of drove us when we started the company, when we were looking at what do we do to, how do we make a big difference in the industry, is we've noticed over the since 2014, we see web application attacks as either the #1 or #2 source, but by far the leading place where attacks are coming from. Yet we find out that a lot of application security budgets or data security center budgets, only like 5% are spent in the application security category. So we saw that there's a problem here. We also have experience with traditional or legacy web application firewalls, and we just weren't really satisfied with how that was going. So that's where Signal Sciences came in. So our big we have more that we do, but one of the things we've noticed is the OWASP top 10 for like looking at the top like web application security problems. That's really only the tip of the iceberg, if you can see our visual iceberg there. We see that there's like real world problems that people need to solve, from account takeovers or bots and scrapers, or abusing business logic. We've seen like the OWASP top 10 kind of gain most of the traction, but there's a lot going on in web applications, in modern web applications, microservices, APIs, whether you're delivering in any type of stack in any cloud. Like there's other types of threat vectors or vulnerabilities that we need to look at. The one way we do this is we give the access for our users this thing we call power rules, and power rules lets you take any part of the HTTP transaction. You're not writing kind of black magic regex here, but you're able to take any inputs that you're given, and you're able to, and any outputs that happen, and create signals out of this that let you take defensive action, monitoring on this. And so we're really excited about this, and this sort of enables and puts you in control of being able to do detection for any type of attacks that you might be dealing with in your system. Well, and just one thing we love to say is, like, we protect any application, whether you're in Kubernetes or in a platform as a service type offering, you're in Amazon, or you're running on any type of web server. From Nginx to IIS to Apache, if you're using proxies, using load balancers, we defend all of that. And we do any attack, like I mentioned earlier, kind of the tip of the iceberg plus everything underneath. And then we work with any DevOps toolchain. So we fit inside of Slack and HipChat and Datadog and PagerDuty, Splunk, Elastic. We integrate to all those tools. And the last slide here, we're just really excited about one thing at Signal Sciences is that we just won this award for Gartner Peer Insights in the Web Application Firewall category. And I think this sort of sums it up. I'll just read one of these, but these are all customer submitted. We won the award without, not the traditional Gartner model with the Peer Insights here. And so unlike the majority of WAF products out there, Signal Sciences does not need hundreds of stateful rules to function properly. We were able to get Signal Sciences up and running within a few days and required only 10 or so rules to get configured and running in full blocking mode. And we're happy to report one of the fun things about our product is that 95% of our customers run us in full blocking mode, which if you're familiar with traditional WAFs, that is not a very normal thing at all. So, okay, well, hey, Will, that's kind of the Signal Sciences commercial bit, but like I said, we're really happy to be partnering with Netflix, and just wanted to let you kick off into your stuff, because I think this is going to be really engaging for everybody.
Great, thanks, James. It's been fun to work with Signal Sciences along this journey as well. But thanks everyone for having me on. As was mentioned, my name is Will Bengtson. I'm a senior security engineer here at Netflix. I'm part of the cloud security infrastructure team. And today I'm going to talk to you about building our Netflix pizza. And what I mean by Netflix pizza is we're going to talk about the different ingredients that we've built over the last couple of years and how we've layered these together to create the gooeyest, most delicious, yet probably disgusting pizza in the world, with the idea that if we can build a pizza so disgusting or so delicious that we'd actually detract adversaries from trying to get to it. So today we're going to talk about some things like credential compromise detection, a tool that Travis wrote called RepoKid, some initiatives called Role Protect, how we do some anomaly detection, how we got rid of static keys in our environment, some key enforcement techniques that we've used, and most importantly, with respect to this webinar, how we were able to use Signal Sciences to kick off mitigating vulnerabilities within our environment. So when we actually started doing this talk, we actually found that there's a World Pizza Championship. Pretty amazing to think that there's actually a championship out there for pizzas. And so that's what we're going to try to do, is build a pizza so well that we could be up there on the top ranks of that championship. So if you think about building a pizza, we're going to start with the crust. And for crust, for us being the team that owns AWS at Netflix, we're going to start with account segmentation. So we're going to build this crust out. We're going to separate our accounts within the cloud out to the granularity that we'd like, in an effort to kind of mitigate blast radius. And if you think about segmentation or blast radius, what you want to do is if the account gets compromised, you want to make sure that you can contain that damage. This is very similar to an analogy that we like to show with a fire break. If you're not familiar with a fire break is basically a controlled burn in order to prevent further damage of a wildfire. Back in the 1900s in San Francisco, there was actually an earthquake and a big fire started out. And one of the things that they actually did to prevent further damage within the city is they just started blowing up a bunch of mansions across, I think it was the Embarcadero or something, where they ended up blowing up a bunch of places, getting ahead of the fire and controlling that burn. And that's what we want to do, is get ahead of the potential malicious adversary, so that if we have a case where we have a compromised account or something like that, we have very good segmentation. The permissions are segmented, and a compromised account doesn't necessarily affect everything. So if we have specific use cases or applications where we need broad permissions, we might actually segment that application out into a separate account so that we can make sure it doesn't affect anything within the main account for us. So if you think about if a adversary were to compromise an account and get hold of it, it would be very limited to the actual compromise. And so this is a screenshot of Dark Tourist from one of our shows. And here we've actually, if you think of the tourist here being a single account that's been compromised, we're separating out the duties, and we're going to make sure that we're successful in limiting that blast radius. It's useful to separate, as I mentioned, the duties, useful for separating sensitive application data. If you think about compliance needs with PCI, HIPAA, whatever industry you might find yourself in, being able to separate applications and data out to respective areas is a very good control. And for us, it allows us to scope things very fine-grained when it comes time for audits and things like that. Now, it's very important as you go about this journey building that crust. If you want to, have an assembly line of accounts and build out, many base for your pizzas, that you build some tooling around creating accounts. And AWS has made this very easy with organizations and allows you to set it up from there. All right, so we've got some crust. Let's get some sauce on this bad boy. We're going to talk about how we removed the static keys at Netflix and came about with putting some pizza sauce there. If you are familiar with static keys within AWS, static keys are the API credentials to actually operate in the cloud. The one problem with static keys is that they never expire. And these have actually led to numerous compromises in the past across industries. So one thing that we didn't want for us is to actually fall in line there. So if you think about what damage could be done with a static key, we can pull up some examples. Here's one where an AWS account was hacked, and they have to pay $50,000 bill, and they're wanting to know how can they reduce the amount they need to pay. So in all these cases, static keys were actually compromised or leaked and brought a lot of money down. So in this case, I was billed for 14,000 USD in Amazon Web Services, where a file containing his credentials were ignored, or were not ignored in Git and published to GitHub. And within the few minutes, they were compromised and a lot of money was spent. In this case, Ryan Heller had an AWS nightmare where a leak access key resulted in a 6,000 bill overnight. So as you can see, static keys can be a problem if not controlled. One of the biggest problems with static keys is it's a common vector of exposure, and there's a bunch of tooling out there that's written and constantly checking for these things. So if you do push a key out there, it is going to be found and it is going to be used against your environment. So one thing that we like, or what we've moved towards, is short-lived keys that we can deliver securely to our developers and applications that are rotated automatically. And this is done through what's called the security token service within AWS. And we issue these to our developers off of their identity and the applications that they own. So a developer can ask for a credential for their given environment, their given application. We'll verify that and push that to them securely. The most important piece is we're pushing these to them with some IP credential locks, as well as they're very short-lived. So even if they were to be exposed, the risk of that exposure is mitigated just by time. On top of that, we're going to start throwing some gooey cheese on top. If you think about credentials, the next obvious thing is to think about is what permissions do these credentials actually have? And so this is where we talk about permission right sizing. So within Netflix, we move very quick. We will mince roles for applications that provide broad sets of access with the idea that we're going to then check later and see what is actually being used and kind of tailor that down. So we continuously and automatically remove unused permissions within our environment for both applications and user roles. So if you think about going to a tailor and getting a role that's tailored perfectly for your application, we err on the move fast. We'll tailor you later instead of going and getting that perfect tailored IAM role from the beginning. So when you're deploying an application here at Netflix, you don't have to speak with the security team up front to get the permissions that you need. We give you a broad set of permissions, and then we're going to take a look at what you do with RepoKit and then take the delta of those permissions back. And what happens is you end up with a very fine-grained access control IAM role for your application and a much least privileged environment for us. The really nice side benefit for this is if you have those stale applications, think about a hack day. A developer developed something, they deployed it in the environment, it was used for a couple of days during the week of hack day, and then it just sat out there. It was forgotten about, but you have this application potentially on the edge that isn't being updated a bit anymore. It's just kind of out there. As you stop exercising the permissions in your IAM role, RepoKit's actually going to pull those down to 0. So eventually that application being unused by any service is going to end up having no permissions on it at all. So we'll definitely limit or mitigate the risk of exposure should it actually be compromised due to not being patched or something like that. And this kit is open, or this tool is open source and available online from our GitHub, and very, very powerful for us. All right, so we've talked about how do we actually get do short-lived tokens, how do we do the tailoring of those permissions, but I'm not a vegetarian, I like to eat meat, so we're gonna throw some pepperoni on this pizza and talk about the paved road for credentials within Netflix. I like to throw this example, the Presidio Modelo in Cuba. If you think about this prison system, you have a central guard shack, and if you think of the cells within the prison as unique AWS accounts and roles, you can see that I, as a guard at the prison, can see into every account, every role. I have full visibility from a central standpoint. And that's really what we're trying to do here with Paved Road for credentials, is develop a central point of entry for all actions within AWS, be it whether you're logging in as a user into the AWS console or you want to develop as an application. And so what we've done is a member of the team had written a tool called ConsoleMe that will allow you to actually mint and craft those credentials for you for your development. So if we walk through what this actually looks like, we have a user on the left, our ConsoleMe tool in the middle, the IAM service, and an identity service internally called Pandora. So as a user, if I want to actually do some development and act as an application, I would ask ConsoleMe for credentials. This happens through a mutual TLS API request where I can actually transmit my identity across. Within Netflix, we do mappings between accounts, roles, applications to different membership of groups. So from here, ConsoleMe can actually take my identity and what I'm requesting and ask Pandora whether or not I'm a member of the proper group that provides access to that particular application or AWS account. Pandora will answer yes or no. If it's no, then ConsoleMe will just simply respond back saying that you're unauthorized. But if it's yes, this is the important part for us, is that ConsoleMe does the assume role into AWS IAM to actually get the temporary credentials that I mentioned before. So we're going to craft credentials anywhere from 15 minutes to 1 hour, and we're going to pass these back to our user. So when console.me requests credentials from AWS IAM, it's going to assume the role for the application or account that the developer has requested. It is going to inject what they call a sub-policy injection, and it's going to, within that policy, lock those credentials down to our development environment, so that if they are used outside, there will be not valid anymore. So the IAM service and STS will hand these access keys and tokens back, and then console.me will transparently pass those back to the developer. So the developer ends up with access locally on their laptop to operate in the cloud as a user of an account or their application. And most importantly, it's all done securely and through a central place. So by doing this through a central place, it buys us a central auditing and logging set of infrastructure. We can see every time a user's requested a particular role. Are they requesting roles that they do not have access to? How often are they requesting it? We can start doing anomaly detection based on you've never requested this role before in the last 90 days, or perhaps you've never requested this many roles within the same day. So having a central place to do that logging and auditing through a control plane of console.me provides us a lot of great benefit through there. And as I mentioned, we can start doing that anomaly detection to see could a user potentially be compromised, and we need to dig a little deeper into the identity of that user. So next, let's throw some olives. I'm not an olive guy, but I am a fan of preventing instance credentials from being used off instance. And so this is a technique that I came up with that I like to call key enforcement. Internally, we call it API protect, but it's essentially trying to figure out if we can craft credentials within AWS or make sure that roles, the IAM primitives within AWS only work within our accounts. And so the idea is if an attacker steals our credentials, they don't work. And so the way that this works is we will enumerate all of our AWS accounts and craft specific managed policies within AWS. And a managed policy, if you're not familiar, is a IAM primitive within AWS that you can actually apply to one or multiple IAM roles or users. So the policy that we actually create is basically a whitelist conditional of what elastic IPs do we have, what static IPs we have, what are our IDs for the VPCs that we operate in, and what VPC endpoints could we potentially make calls from. It creates this master policy in each account and then starts applying them methodically through the environment to safeguard those credentials for those applications to not be used outside of our environment. And an in real life example is we had some credentials exposed via a third-party application. The bug bounty researcher that pulled those credentials off were unable to actually use them from their local system due to the API protect or key enforcement that we had applied to it. So we actually saw a real-life scenario where this worked, and it was really kind of cool to see that affirmation at the end that this is actually working and building that layered pizza is having a great effect. So let's throw some mushrooms on top and talk about how we actually lock down delivery within our environment. So I mentioned earlier that we need to develop an application. We're going to grant you permissions that are pretty broad from the beginning. It's probably well known that Netflix uses a delivery tool called Spinnaker. It's a tool that we wrote internally, but has been a great community effort, including companies like Google and many others, that it's a very well adopted tool across the board now. So we use Spinnaker for delivery and deployment of our applications. So when you deploy an application for the first time, Spinnaker is calling into our infrastructure and saying, hey, will you please create a role for this new application? We'll create that role and then the application deploys as usual. Spinnaker can be configured in many different ways for locking down delivery. A typical way for locking down delivery is if you have access to that account, then you have access to the applications that Spinnaker deploys in that account. It's a pretty typical model, but we wanted to make sure that you couldn't do anything beyond what you should. in many cloud models, you're not just the only application running in that account. So you're going to be co-located with other accounts, potentially, or other applications, potentially other teams. And we wanted to make sure that you could not potentially privilege escalate your application by using another application's role. So if you think about the scenario where you have two applications in the cloud, one has a very permissive role and one doesn't. If I needed access to more permissions, what's from stopping me from actually deploying with that other role? And so that's where we are using features within Spinnaker to tag application and roles to whitelist what can actually be used. And so now at Netflix, if you want to deploy an application, you can only use the role that's specified for that application. The minute you try to not use, or to use a different role, you get denied and we get alerted, so we can see that, hey, there's something potentially going on, privilege escalator. Maybe we need to reach out proactively to that developer to see, are they needing more permissions? On top of that, Google actually contributed back to Spinnaker with a auth-z model called Fiat. And what Fiat allows you to do is tie application changes specifically to the owner of that application. So once you are identified as an owner and you enable Fiat, only members of that ownership group can make changes to the application. And this includes deployment. So no longer can someone deploy your application without your knowledge. And it allows us to get some really fine-grained controls about, especially around our very sensitive applications of, what's happening and when. So with these two together, we're preventing privilege escalation within our environment, and it's being shown to be very, very positive. We rolled this out environment-wide, and it allows us to continue on this kind of automated detection and alerting that allows us to continue building that pizza and getting many, many wins in our environment. All right, let's spice some things up and talk about detecting instance credentials used off our environment. So originally came up with this concept, I think early last year, of how could we actually detect AWS credentials being used outside of Netflix's AWS environment. So we have this idea of, well, we're already blocking potential use with API Protect or the key enforcement. We know that potentially there's some gaps there. So can we talk about, or can we figure out how credentials are used outside of our AWS environment? So we came up with a methodology that would allow us to learn those temporary keys that are minted, learn where they're being, or when they're created, track when they're first used, and then compare use after that. So if you think about the first time you create a key, I use it from this IP. Every other use of that key should come from the same IP. So we track use of temporary credentials to the source IP that we've locked to and alert outside of that. Another example of this is very similar to the previous one. This, probably the same situation where we had a key exposure due to a researcher in a third-party application, and we were able to actually detect use of this credential outside of our environment by doing some analysis of the source IP to when it was actually used prior. All right, we spiced some things up. Now let's talk about some onions on top of that pizza. So we've talked about key enforcement. We've talked about detecting credentials outside of the environment, but can we actually detect use of credentials on box, but that aren't within the normal behavior? So detecting anomalous behavior in our environment. In order to do so, we track baseline behavior for an account. And what that actually looks like is within AWS, you have CloudTrail, which is the audit source. And so we're actually making logs into what actions and services have we seen be used at Netflix. We have a pretty standard, what we call the paved road. Typically, a lot of applications act similar to one another. We have a core set of AWS services that we use. So let's see if we can track the specific API calls that we're actually looking or actually using regularly. So within AWS, we use some regions, we use some resources, and we use particular services. And outside of that, these typically aren't used. And so we continuously watch CloudTrail. We log when we've had actions called in the past. And so the first time we see an action, we're going to log it and we're going to alert on it. And then when we've seen that action after the fact, we know that we've seen it before, so there's nothing really to be concerned about. And so an example of this kind of methodology is we're doing an internal pen test, and one of our employees hopped on a box, started running an enumeration script. And in that enumeration script, it called an EC2 API call that we've never called in the history of Netflix. Our CloudTrail anomaly detection picked that up and alerted us to the fact that, hey, we've never made this call before. In this account, this call was made. We should probably check that out. So we've seen how powerful that could be from a, we've never seen this call in the entirety of Netflix in this account. We questioned the fact on whether we could actually make this even more powerful and, the pizza even more disgusting and throw some barracudas on top or some anchovies, whatever you want to call it. When we were actually developing this slide, our vice president was walking by and was like, why would you put a barracuda on that pizza? That looks disgusting. And it's exactly as I mentioned, we want to build the most delicious or disgusting pizza that either you don't want to try it, or it's got so much on it that you can't finish that pizza. So we're adapting the previous idea of anomaly detection based on an account, but we're now going to dwindle down to the specific IAM role level. As I mentioned before, every application in our environment gets a unique role. So over time, we can learn what a particular application does, what's normal. So they should have relatively consistent behavior. All applications within our environment should be exercised normally across a period of time. And so the only time that we should see anything vary outside of that is if there's been development on that application and they're expanding the particular use case. So we'll learn an application over a period of a month or so, determine what calls are actually normal, and then start doing that same sort of alerting outside of that. So we might look for some very first common steps that an attacker might make: list buckets, list access key, get caller identity. So this is get caller identity is kind of like the who am I in Linux, but within AWS. So we're alerting on API calls outside the norm for our particular application role. So you could be on box and still do something that the application normally didn't do, even though the call came from within our environment. All the call succeeded, it would still alert because we've never seen that application make that call before. And an example of this working is we had a new developer within Netflix that was working late one night, was curious about contents of or what buckets we had in one of our accounts, hopped on their application and did an S3 list buckets call. And then our detection picked that up and alerted us to investigate and see. We ended up having a conversation, and all was normal. But for us, we know this will be something that will be very useful in the future for us for potentially detecting compromise should we have a vulnerability in an application that we did not know. So enough of the graphical pizzas. Let's hop into some real delicious pizza that we'd actually want to eat and talk about some of the future work that we're doing. So some future work that we're doing is along the same lines of one role per application. We're expanding this out to one role per user. So if you think about, I'm a user accessing the AWS console, there's probably some particular things that I do based on my role on the team that others might do differently based on their roles of their team, but we still might operate within the same account. Currently, roles for users within Netflix and I think many other companies are shared across numerous people. The idea of dynamically creating one role per user as you first log into the account allows us to do some things very similar to our applications, in that we could start looking at the permissions that you're actually using versus what we gave you and start repoing those down. So if you think about at this point, your role becomes very unique to you and your role at Netflix. And so that your IAM role within AWS becomes your unique fingerprint within the environment. And then we can expand the anomalous behavior detection to particular users as well. So if you're an admin and you normally only do these various things in an account, the minute you do something outside of that scope, we potentially can be alerted and start digging in a little more. Along the same lines of users, if if you aren't using your user role, it's eventually going to be dwindled down to 0. It's very similar to the analogy of an application. When I mentioned that the hack day, if you have an application that's just been forgotten about, eventually the permissions of that application are going to go to 0. Same thing for users. If they stop using an account, potentially their permissions will just go away. Or we can actually start looking at, if you think of the Presidio Modelo model, we know when users are actually logging into accounts. Perhaps we just remove their access proactively from the beginning so that we can not even have the chance of that compromise due to a compromised user workstation. So it's going to reduce that risk of a compromised workstation and allow us to continue to sleep at night. All right, now to the work that I promised about our initial partnership with Signal Sciences from my team perspective at least, the metadata work. Within AWS, credentials are provided to your services for an EC2 server through what's called the metadata service. The metadata service provides you a lot of different information about that server running in AWS. It'll tell you your IP address, potentially what account, VPC, a lot of different information, but most importantly for your applications running in AWS, and unfortunately also for the attackers that are attacking your infrastructure, it's the credential source for your application. And so in the metadata work, we are going to try to prevent compromise at the credential source. When you talk to numerous companies that run bug bounties in the cloud, one common point that you might find is that the minute an attacker finds a vulnerability such as server-side request forgery, XML, external entity injection, or something like that, where they're able to trick an application to make a web request on their behalf, the most common attack vector is to point that application at the AWS metadata service. And so what we wanted to do was figure out how could we detect this kind of attack and potentially prevent it altogether. So we started working with Signal Sciences. I've been lucky to know some of the co-founders for a long time and been able to just kind of throw ideas at them. And so it was like, hey, Zane, Andrew, James, let's figure out how we can actually do this. We're using Signal Sciences. Can we actually build a power rule on detecting SSRF? And more specifically, can we detect SSRF of the credential source? And so let's figure out a rule set that we can put together and detect that kind of SSRF vector and potentially monitor a use case. What do the applications look like now? Potentially alert on certain endpoints within the metadata service, and then most importantly, block on other endpoints. So an ability to actually get some intelligence, some alerting, and potentially blocking all together. So we built that out and tested that. Worked really well. And then we took it one step further so that we could have, yet again, one more layer of the pizza. And so I'm going to walk through what the SSRF looks like. So you can kind of envision how Signal Sciences could detect that. And then the second layer that we've come up with to actually make sure that we both get that alert in Signal Sciences, and if it's in a pass-through mode and just a monitor and not a block, that we could actually block at a different level if we wanted. So within SSRF, you've got a malicious actor on the left making a web request to an application there in the middle. The web application is making a remote web request to a remote app. It's handling that response, putting it together with everything else, and then sending that response back to the malicious actor. The malicious actor sees that, hey, there's a potential opportunity for SSRF vector, and so the malicious actor is actually going to try to get metadata credentials. So it's going to make a web request. It's going to send the URL or the IP address for the metadata service endpoint within AWS, more specifically the security credential path, and then that web application is going to make that request back to the metadata service and then provide the credentials back to that malicious actor. And so here's the level where we'd actually get Signal Sciences actually alerting on this type of request. The Signal Sciences WAF can detect that kind of URL, I guess, URL pattern and start monitoring it and or potentially block on that, and give us some real-time intel. So that was our first kind of look at it. Is we're already using this. Can we leverage it to do some detection and blocking? Knowing that in security you want multiple layers of defense, we went ahead and took it one step further and started looking at what do requests to the metadata service actually look like from trusted sources that should actually be getting credentials. And in AWS, when you think of trusted sources, it typically comes down to the AWS Software Development Kit, SDKs. And we made a bunch of PRs to the Amazon SDKs to actually set user agents when making requests to the metadata service. And so now if you make a request, if we take an example of a Python application, we have a Python application that needs credentials from the metadata service. We've built a metadata proxy that can run locally on your system that would check user agents and make sure that they match to what a SDK would provide. One important piece with the server-side request forgery or XXC vulnerability vector is that malicious actors typically cannot control HTTP headers. And so they cannot control the user agent that's actually being sent across when making a request to that remote application, as in the previous example. So in this case, the Python SDK is asking for credentials for a role called my role. The user agent here is being set as boto3/version/uname, various different data within that user agent. The metadata proxy is checking to see if that's a user agent pattern that it knows. And if it is, it's letting that actual HTTP request pass through and get the actual credentials from the metadata service and pass those back to the SDK. In the case that you have an SSRF or an XXC vector being exploited, this vulnerable application, Python once again, would be making the request, would be tricked to making that request to the metadata service. In this case, if we assume the application's using a popular HTTP request library called requests, the default user agent that library would use is python-requests/version/uname. And so in this case, as a malicious actor, I've attempted to trick the application to requesting credentials on my behalf. And the metadata proxy sitting there on box locally, and from the metadata service is actually going to intercept that and say, hey, this isn't what I expect. I'm going to actually block it. So we'd have blocking at the WAF level as well as a second line if there was a bypass at the WAF level to actually block at the instance level as well. So to sum this up, we have a very delicious yet disgusting pizza. Many ingredients and toppings that either you like or you don't, with the idea that this pizza becomes overwhelming for that malicious actor and they can't eat it at all, can't get through all of it, or it's just so disgusting that they don't even want to attempt to try it. So one last analogy, Ultimate Beastmaster, I've got to do my plug for Netflix. If you think about the show, if you've ever seen this, it's like American Ninja Warrior. It's each obstacle in of itself is very challenging. They have very athletic and capable competitors on this, but each obstacle by itself is grueling, difficult. But when you put it all together and chain them all layer after layer, it becomes almost impossible to get through. And that's what we've tried to do with building that Netflix pizza. And so to wrap things up, we've got many ingredients. We apply them in multiple different ways, all with the idea that we are going to continuously mitigate the risk and detection of compromise within our accounts. And with that, I'll throw it back over to James for some Q&A.
All right. Hey, that was great. I really like that, Will. Let's see, if people have questions, they can submit them. Alan, if we're seeing any come in, you want to flag us on it. But yeah, it's great. Will, one of the things I love about watching, I was watching Jason Chan give a talk, I guess about a year ago or so, but it's like I've learned new shows on Netflix that I want to now watch. So that's if you guys watch Netflix presentations, that's always a great thing. Okay, cool. So let's see if we have any questions coming in.
James, I'm here. I'm not, maybe it's me. I got people saying cool, thanks, appreciate it. But no one asking any tough questions here for Will.
All right. So,
Nice
Will,
as well. Go ahead.
yeah,
I'm sorry.
yeah, go ahead. Yeah. So, Will, when people are getting started, I mean, like one of the things is I like how you guys have all these different layers on here. Top, 3 things that people should do whenever they're kind of taking an approach like this.
Yeah, so the top 3 things I think, especially if you're just starting in AWS, uh, if you can get your account segmentation off the bat, it makes developing much easier. It's definitely a lot easier to start in multiple accounts than to try to migrate to that method. Anytime you can avoid static keys is obviously beneficial. Uh, and then I would say permission right sizing is probably the last piece there. If you can do those things correctly, uh, you can limit the amount of risk or exposure if a credential was to be compromised, and perhaps not having uh, the detections there. I guess it's more important to get your IAM correct first and your account segmentation set up, so that then you can layer those other protections after the fact. And so that's why we put that like crust, sauce, cheese. Is those are
Mhm.
the 3 things that you have to start almost any pizza with. And so those would be the 3 I would recommend.
Okay. Yeah. Do you ever have the problem where you've kind of right-sized the IAM role, or and then later it's like, I want to do something new, but then it's like it's blocked and it's unclear to developers or to folks who are trying to build something new. It's like, hey, why is this not working? It should work. Like I have a novel thing that I want to add to my application. Does that ever become a problem?
It was definitely I wouldn't say a problem, but like a speed bump when we first rolled RepoKit out of actually pulling permissions back, is that when you did want to expand your application use case, you potentially hit that speed bump of you didn't have the permission that you once had.
Hmm.
But we're working day in day out to try to make that less of make it a smaller speed bump than anything. So actually, right now we're building out some self-service IAM tooling that would allow you as a developer to just go request that back right away. So you wouldn't even have to talk to us. But right now it's a simple just conversation in our security help channel, and then we understand what you're trying to do. We give you the permission, and it makes it really easy because a lot of times our developers aren't necessarily as deep knowledge in AWS as we are, and so they really just need to tell us this is what I'm trying to do, and then we translate that down to the actual permissions that they need. So we're trying to figure out the best way from a self-service model of providing that same mechanism to our user base.
A couple years ago, I was trying some experimentation with like getting Lambda running, and I had said, okay, I'm going to do the best thing. I'm going to create a really strict IAM role and all that sort of stuff. And the framework I was using, I was like, okay, I got a log that says, open up this permission to this bucket or whatever, right? And so then after like 3 or 4 of those, like I just gave up. I was like, I can't do this. Like this is just going so slow. So I just star and said, okay, I'll fix it later, right? And I think that's you're right. Like developers, like when building something, it's like I just want I want that flexibility, and then kind of lock it down, and then fit it to the right size. So yeah, that makes sense. I think RepoKit's that's a really exciting project. One of the questions we had in here is, can you please provide reference URLs to all these various tools and libraries?
Oh
Is
yeah,
this just like GitHub
they're,
Netflix?
yeah, they're
Or
mostly on GitHub, github.com/Netflix or github.com/Netflix-skunkworks. Those are our 2 GitHub organizations,
okay.
and majority of these, if they're open source, they're on that on those 2 GitHub pages.
Yeah, you guys have a great history of always releasing lots of cool open source stuff. So yeah, github.com/Netflix, or what was that other one you said? Skunkworks, Netflix Skunkworks?
Yeah, github.com/Netflix-skunkworks.
Okay, great. All right, let's see. Sorting here through some questions. The one question is, can you clarify why you think it is hard to change HTTP headers and user agents? Not sure the context on that.
Yeah, so if I understand the vectors of SSRF correctly, you typically can only control the domain or the URL that you're trying to request. And so unless the application is actually accepting like a CRLF, you wouldn't actually be able to then push headers into that request as well. So at least the exploitations that we've seen, you're unable to control the headers, and so that's why that proxy method is effective for us.
Okay, that's great. Question here on console.me. Would something like Okta or OneConnect fulfill what that's doing if, say, people didn't want to run their own in-house?
Yeah, if you want to use Okta or OneConnect to do that SAML federation into your accounts, it definitely could be your central computing resource there. For us, by running one in-house, it gave us a lot more fine-grained control of what maps to what for access, and allowed us to actually do the application level role assumption as well, and not just tackle it from a console perspective. So we're able to get those CLI type developer credentials for anything in our environment. But I assume you would be able to do something very similar with an Okta or OneConnect.
Okay, yeah. Here's a question for you. What kind of computing resources are required when you're using CloudTrail and calculating anomalous behavior? They're worried there's a lot of extra heavy lifting that has to happen there. Are you using like some lambdas to sort through it, or what do you got?
Yeah, so we are. It's essentially for us. We have an EC2 server that's making an aggregate CloudTrail query, and then routing those calls to a Dynamo database. So it's essentially an EC2 server, a DynamoDB as a storage backend, and then your whatever source your CloudTrail is stored in. So it could be you're querying Athena. In our case, we're querying Elasticsearch to get the actions for us. But we're pushing unique role actions into Dynamo, and we're using the Dynamo feature of the TTL, where Dynamo is actually cleaning up the table for us. So we just have this loop running on a cron that's checking for the last n minutes of actions per role, and then it's updating the table and setting a TTL value of that action. And then as applications stop using permissions, those actions just fall off the Dynamo table. So when we see a new permission, we just do a query that says, has this role ever made this call? If the result's 0, then it's an anomalous detection for us.
Okay, great. All right.
Yeah, so not as much as I think it might seem, but it's pretty straightforward.
Mm-hmm. Yeah. All right. Any other questions through here? I feel like that's great. I think this is a really great overview. And Alan, I guess we'll turn it back over to you on your end.
Sure. Well, first of all, James and Will, thanks so much. I will tell you, James, you alluded to Netflix history of open sourcing, and so much of what they've done, the Chaos Monkey stuff and all of that. But the whole Netflix culture has been one of, hey, we've learned lessons, and we're gonna kind of share our lessons learned with you, and hopefully you don't have to pay the idiot tax. And more importantly, making the tools available that we've developed internally. So, and this goes back to Adrian and some of the early stuff there, but thanks so much, Will, to you and the Netflix team for doing what you guys do. I think it helps a lot of us out there. I wanted, as I mentioned earlier, we're giving away $50 Amazon gift card to folks who stay in and listen. So I wanted to announce our winners. It looks like we've got Bruce Conrad is one of our winners. Bruce, thanks for being here the whole time and paying attention. Hope you enjoy your gift card. Our next is Charlene. I'm going to mispronounce her name, but it's Burchett. Does that make sense? So Charlene Burchett, thank you. If I mispronounce your name, Charlene, please don't hold it against me. Bruce Conrad was the other one. I just got to write these down, guys, so we make sure we get them their gift cards. And then let's see, who else do we have here? How about Fernando Para with a P? That's Fernando Para. And I think we have one more here to do. Thomas Pavin, another P. Guys, I think that's 5, right? And if that's, enjoy your gift cards, everyone. Oh, no, we need one more, I'm told. I'm sorry. Let's do Wayne Chang. Wayne, thanks for sitting in. So guys, that's our gift cards. We're giving these away on all of our gift cards. Let your friend on all of our webinars. Let your friends know. It's just a little thank you from us over here at Media Ops, producers of DevOps.com, Security Boulevard, and Container Journal. James Wickett, I'll see you next week at the RSA conference and DevSec Connect DevSecOps Days, correct?
Yep, we'll be there.
Looking forward to it. Will, again, thanks to you and all of the Netflix team for doing what you guys do, and it helps the community at large. And thanks for appearing on our webinar today.
Thanks for having me.
My pleasure. If that's it, we're going to call it a wrap on this Web Security Boulevard webinar. For those who maybe just joined in or whatever, slides, recording will be available probably within the next few hours on YouTube and as well as securityboulevard.com. Until the next webinar, though, thanks everyone for joining us today. This is Alan Schummel for Media Ops, DevOps.com, Container Journal. Again, thanks to Signal Sciences for sponsoring. Have a great day, everyone.